I'm Anil Kumar and will explore discontinuities of rational functions. Now the question before us is, consider a rational function of the form f of x equals to px over qx, where p and q are polynomials, right? Explain the possible types of discontinuities which the function can have at x equals to c if qc is 0. So what we are given that there exists a point c in the domain of polynomial q of x where qc is equals to 0. In that case, you need to explain possible discontinuities. Well, if qc is equals to 0, then there are two possible discontinuities. One could be leading to whole and the other could lead to vertical asymptote. That is what is very important for you to understand, right? So in chapter 4, we are going to basically explore vertical asymptotes in more details, but this is extremely important to understand that whenever the denominator is 0, in that case there is a possibility of a whole or a vertical asymptote, right? So these are both the cases. Now let's take a few examples to make the point clear. So if I have a function, let us say, if I have a function which is, let us say, x squared minus 1. So here x, the numerator will be 0 for x plus 1 and x minus 1. And if I have denominator as x plus 1, in that case, what do we expect? So in that case, we do have a common factor in numerator and denominator. So we could write this as two factors in the numerator. One is x plus 1 and the other one is x minus 1 divided by x plus 1. Now in this case, as you can see, x plus 1 cancels out, right? So what we have here is basically we have a whole, right? So we have a whole at x equals to minus 1. We do not have any vertical asymptote. You get the idea? We do not have any vertical asymptote. Numerator was 0 for x equals to minus 1, right? But it resulted into a whole, right? On the other hand, if we have a function, let us say g of x, which is, let us say, 2x over x plus 1. Now in this case, at x equals to minus 1, we have a vertical asymptote, right? So at x equals to minus 1, we have a vertical asymptote at x equals to minus 1, since at minus 1, denominator is 0, but not the numerator. So there is no common factor. So if there is no common factor between numerator and denominator, we'll always get a vertical asymptote, right? So in general, this is the scenario. Well, there is a very special case which I like to highlight here. We could have a function h of x, for example, in which we could have a function like x times x plus 1 divided by, for example, x squared. Now in this particular function, we do have at x equals to 0, numerator is 0 and denominator is also 0. We do have a common factor which cancels off. So what do we expect? We expect a whole, but still we have 1x remaining in the denominator. So that really results into not a whole, but it also results into vertical asymptote at x equals to 0, right? So at times, in spite of the fact that we have a common factor in numerator and denominator, we may not have a whole, right? So that is kind of very important to understand. So for a whole, it is important that both have common factor. In that case, there is a possibility of a whole, right? And for a vertical asymptote also, it is possible that if numerator is also 0 for the same factor, we still get a vertical asymptote, not a whole, right? So that is another thing which we need to keep in mind. But in general, we get a vertical asymptote if the denominator is 0 but not the numerator. That statement is always right. So if denominator is 0 and not the numerator for the same number, in that case we do have a vertical asymptote. However, if denominator is 0 and numerator is also 0, we need to check their degree. Whose degree is higher, right? If the degree of both is same, then we get a whole. If degree of denominator is higher, we get vertical asymptote, right? So there could be a scenario like that which you should keep in mind. I hope that helps. Thank you and all the best.